an ancient alien object is swiftly approaching our sun. For the past month, Earth's most powerful telescopes have been focused on this peculiar light in the sky, seeking answers. However, their observations have only generated more questions, and time is quickly diminishing. The object will soon vanish from our sight, obscured by the sun's intense glare, leaving us with a cosmic enigma. What exactly is it? Officially, it's named 3I Atlas, signifying third interstellar object, indicating its origin from one of the distant stars visible in the night sky. While its precise origin remains uncertain, it's highly probable that 3I Atlas originated from an ancient region within our Milky Way galaxy, potentially from a solar system twice the age of our own sun. This marks only the third instance we've observed such an interstellar visitor. The first was Oumuamua, a peculiar cigar-shaped rock that entered our solar system in 2017. The nature of Oumuamua is still largely unknown, but its strangeness was undeniable. 3I Atlas appears to be even more unusual. Following Oumuamua was 2I/Borisov, which is often considered the less remarkable of the three because it behaved much more like a typical comet. It behaved as a comet, and was almost certainly one, though it originated from another star, which is still quite fascinating. However, 3I Atlas has rapidly emerged as our prime chance to investigate a truly enigmatic alien object. It's a situation where new discoveries only add to its bizarre nature. Officially, the Asteroid Terrestrial Impact Last Alert System, ATLAS, first detected the object on July 1, 2025, giving it its name. At that point, it was situated between Jupiter and Mars, closer to Jupiter. Subsequent analysis, however, revealed that the Transiting Exoplanet Survey Satellite, TESS, which typically observes distant alien planets, had initially observed 3I Atlas on May 7, 2025. Therefore, TESS did not initially identify it as a new visitor. When the first image of 3I Atlas was captured, it was located between Saturn and Jupiter, providing an indication of its speed. For comparison, NASA's Voyager probes took 18 to 23 months to reach Jupiter's orbit on a direct trajectory. We understand that 3I Atlas was near Jupiter in May. It is currently passing Mars in September and will make its closest approach to the Sun on October 29th. By next spring, it will return to Jupiter's orbit. This trajectory confirms its interstellar nature, as it is moving too rapidly to be captured by the Sun's gravity, characteristic of a hyperbolic path. A curious aspect of TESS's observation is that 3I Atlas was remarkably bright even beyond Jupiter's orbit, and it intensified further during the 3-week period TESS observed it. This behavior is unusual, especially when compared to typical comets. Generally, comets consist of large masses of frozen water intermingled with rocks, dust, and gas from the outer reaches of the solar system. As such an icy mass approaches the Sun, it heats up and begins to melt. In the vacuum of space, this phenomenon is scientifically termed sublimation, as liquid water cannot exist. Consequently, the ice directly transforms into gas, forming the large, bright, fuzzy halo around the comet, known as the coma. This is significant because typical ice-water comets do not warm sufficiently to sublimate and develop a coma until they have passed Jupiter's orbit and are nearing the asteroid belt. However, when TESS first observed 3I Atlas on May 7th, the object was far beyond Jupiter's orbit, yet already intensely bright and increasing in luminosity daily, suggesting that sublimation had already started. This implies that 3I Atlas is indeed a comet. It behaves quite differently from any comet previously encountered. Its behavior is dramatically different from Oumuamua, which notoriously displayed no signs of sublimation or a coma. They are almost antithetical. It also differs from 2I/Borisov, which exhibited typical cometary behavior, making its familiarity somewhat peculiar for such an unusual object. Nevertheless, as observations of 3I Atlas continued throughout July and August, its behavior became increasingly bizarre. While a coma typically forms a tail, which is common for comets, the tail of 3I Atlas began to develop in the incorrect direction, pointing towards the Sun. The Sun, as we know, is the primary source of light, heat, and energy in our solar system. Furthermore, we must consider the Sun as a powerful fan constantly emitting solar wind. This solar wind is usually responsible for shaping a comet's tail, pushing back the rapidly expanding gas and dust cloud to form a trailing effect, much like a dog's face being pushed back by air when sticking its head out a car window. It's a charming image. Now imagine if the dog's face stretched forward. That would defy logic, wouldn't it? This analogy illustrates why observers were puzzled when 3I Atlas's tail appeared to form in the Sun's direction, contrary to the solar wind. These are merely a few of the numerous questions astronomers sought to answer by directing the world's most advanced space telescopes, including Hubble, James Webb, and Sphere-X, a peculiar cone-shaped satellite designed to study the universe's origins, towards 3I Atlas. TESS was also redeployed to re-examine 3I Atlas. As NASA's most sophisticated observatory, it offered the most profound insights into the true nature of 3I Atlas, yielding both answers and new questions. The most significant discovery was that the coma around 3I Atlas consists almost entirely of carbon dioxide, indicating that it is not primarily a mass of water ice like familiar comets. While it does contain some water, the CO2 to H2O ratio is an astonishing 8:1, implying that this object possesses 16 times more CO2 than an average comet. Furthermore, the carbon dioxide cloud surrounding the object is now estimated to be immense, with a radius reaching up to 300,000 kilometers. This radius is nearly half the size of the Sun, far exceeding initial July observations. This has led observers to speculate that the solid core at the cloud's center might also be larger than previously assumed. Initially, the core of 3I Atlas was estimated to be up to 20 kilometers wide, then revised down to approximately 11 kilometers. However, current observations suggest its actual size could be as large as 46 kilometers across. While substantial, it's not unprecedented, as comets with cores over 100 kilometers wide exist in our solar system. Nevertheless, the disproportionately high amount of CO2 relative to water is a phenomenon never before observed. This composition is essentially the inverse of what one would anticipate in a comet's halo, implying that this object originated in a star system with fundamentally different raw materials than our own. The skewed ratios highlight 3I Atlas's genuinely alien characteristics. But was it constructed by extraterrestrials? Another strange discovery emerged this summer during observations of 3I Atlas by the Very Large Telescope in Chile. Yes, that is its actual name, and it is indeed enormous. Intriguingly, the VLT detected nickel metal in 3I Atlas's coma, but found no trace of iron metal. Perplexing, right? Iron and nickel are naturally co-occurring elements, being the most abundant heavy metals in the known universe. This is due to their formation in the cores of dying stars and subsequent dispersal into space by supernova explosions, a truly epic process. Consequently, iron and nickel are consistently found together in cosmic bodies, such as asteroids, moons, and planetary cores. The sole instance of nickel appearing independently is when humans intentionally separate the two metals through industrial means. Thus, the question arises, how did nickel become present in a comet without accompanying iron? An excellent question, and one without a definitive answer, making it quite strange. Naturally, this leads to the popular hypothesis of alien involvement, with numerous theories speculating about the possibility of an artificial spacecraft. To be fair to these theorists, their ideas aren't entirely unfounded. They base their interpretations on known data, offering slightly more speculative possibilities. For instance, 3I Atlas became brighter as it passed Jupiter. While its proximity to the Sun contributed, it doesn't fully explain the significant increase in brightness. This phenomenon could be attributed to early sublimation, given the object's exceptionally high CO2 content, or it might suggest an alien space probe activating its lights. Another theory posits that the CO2 cloud surrounding the object is the exhaust of a colossal spaceship teeming with living organisms, exhaling CO2 and expelling waste into space, much like us. I've even encountered speculation that 3I Atlas itself could be a massive living organism, consuming dust and gas as it traverses the solar system and releasing CO2 as an organic byproduct. What's intriguing is that currently no one can definitively disprove this theory, though it's likely not the case. Similarly, regarding the nickel metal discovery, its implications remain uncertain. Therefore, one cannot definitively rule out the possibility of an artificially constructed alien spacecraft, though it's probably unlikely. This uncertainty is precisely why scientists and astronomers are rapidly endeavoring to gather as much information as possible about 3I Atlas within the limited observational window. In early October, we'll have a chance to photograph this object as it approaches Mars, coming within approximately 28 million kilometers. While still a considerable distance, it's close enough for two European Mars orbiters, the Mars Express and ExoMars Trace Gas Orbiter, to conduct detailed observations of 3I Atlas using high-resolution cameras and color imaging systems. While a close-up photograph isn't expected, the resolution should be sufficient to differentiate between the gas cloud enveloping the object and its central core. This could provide clues about the object's actual shape. By late October, from Earth's perspective, 3I Atlas will pass behind the Sun, rendering it invisible until December, when it will be outbound from the solar system. However, we will have one final opportunity. On March 16, 2026, 3I Atlas will pass Jupiter at a distance of 53 million kilometers. While still quite far, the Juno probe, an older spacecraft in Jupiter's orbit since 2016, remains active. Its scientific mission is currently slated to conclude in September 2025. NASA had intended to crash Juno into Jupiter for disposal and to observe the resulting phenomena. However, an alternative end-of-mission scenario could involve attempting to intercept 3I Atlas as it exits the solar system. Therefore, despite the peculiar nature of our observations of this object so far, our study is far from complete. Much remains to be learned. We anticipate finding answers, but likely also encountering an equal number of new questions, and that, ultimately, is the most exciting aspect of this endeavor.